Reading 4 concerns how we learn to avoid unpleasant situations, as well as there's a section on the use of punishment and some of the issues involved in punishment. So first off, escape and avoidance of unpleasant situations. So again, this whole section is all about how unpleasant, painful, or just irritating environments affect us. And so imagine that you're at work or at school and the fire alarm sounds. Now you know there's no fire, it's just a test. But if you've ever been in the classroom buildings when the fire alarm goes off, it's extremely loud. So it's really, really like painful to the ears. So that loud fire alarm typically, makes us want to leave the area really, really quickly. We leave the area to escape the noise. So escape is when you leave after the fire alarm has gone off. But if the fire alarm sounds every day at 2 p.m., you're going to figure this out pretty quick, and you may start to avoid that area at 2 p.m. every day, or a little bit before 2 p.m. every day. So we usually respond to aversive events, these unpleasant events, by either, one, making a response that will let us escape it, or two, making a response that will let us avoid it entirely. So escaping the aversive event involves just being motivated to get out of there, right? So it's a really painful or irritating stimulus to be around, and we're motivated to get away from there, to escape. So think of what reinforces your escaping of the loud fire alarm noise. Is it positive or negative reinforcement? So when you escape, when you leave the building where the fire alarm is going off, we can think of that as being your response. And then as you get far enough away from the building, you essentially eliminate the sound of the alarm, and that's the outcome. So turning off the alarm or getting far enough away from the alarm stops you from having to hear the alarm. Is that a form of positive or negative reinforcement? When something is taken away, we use the term negative. So here in this context, the word negative indicates not that it's bad, but that something is being taken away, it's being removed. And because the thing that's being removed in this case is something that we don't want, that's unpleasant for us, then that's actually a form of reinforcement. And so that would be negative reinforcement. In contrast, avoidance learning is where we learn to avoid the fire alarm entirely. The reading describes a study by Baktarov where participants placed their finger on a metal plate. And first they heard a tone though, right? So they hear this beep. They already have their finger on this metal plate. And shortly after the beep, they get just a brief little shock. And no matter how brief or how small a shock is, it's kind of unpleasant. So they quickly remove their finger from the metal plate once the shock comes on, right? And so they quickly learned to remove their finger when they heard the tone or the beep so that they could avoid the shock, right? So beep, shock, beep, shock. Pretty soon as you hear the beep, you don't wait around for the shock. You remove your finger and avoid the shock entirely. Okay, so again, escape happens after the shock comes on, when you're first kind of figuring out what's going on. But once you figure it out and you know that the beep is going to signal the shock, you can avoid the shock entirely by removing your finger once the beep comes on. So escape versus avoidance. Now here's the basic procedure for how early researchers studied avoidance learning. They would turn on the light for 20 seconds, and this is in a cage that a rat would be placed in. And the cage was kind of long, and it had this little barrier in the middle, just kind of a short little wall that the rat could jump over if it wanted to. So the rat's over here on the left side. This little light comes on for about 20 seconds. After 20 seconds of the light being on, the shock comes on. And of course, very unpleasant. If the only way that the rat can sort of turn this off is if it jumps over to the other side of the compartment and can escape the shock over here. And so here we can see that the rat at first is going to see the light, experience the shock, and then eventually will jump over here on the side. Phew, what a relief. That will turn off the shock. So at first, this is what happens. A tone can come on or a light can come on, then the shock, and then the jump. And so we see that this is classic escape, right? The rat is escaping the shock by jumping. But after several trials, what would you start doing if you're in this situation, right? Once you hear the tone or see a beep, hear a tone or see a light come on that signals the shock, you're probably going to start trying to get over to the other side as soon as this signal comes on, the tone or the light. So you're going to try to avoid the shock entirely. So the animals hear a tone or see a light that signals the coming shock. They jump before the shock can come on. That jumping turns off the tone or the light, and of course they don't get any shock. They avoid it. So this is the recipe for avoidance learning. So what are some real life examples of avoidance learning? I might slow down on University Drive to avoid getting a speeding ticket. I probably don't answer my phone if I don't recognize the caller because I want to avoid a sales call. I may drive safely to avoid an accident. I might avoid talking to mean people if I can. And I might avoid drinking too much, for example, to avoid several bad outcomes. So in all of these examples, it's better to avoid the painful situation than to escape it. But there's one really strange aspect of avoidance learning. And in the animal research, it showed up by the researchers being able to disconnect the shock entirely, but the animals would continue to jump on and on and on. So in other words, once they learned to jump when the light or the tone comes on that preceded the shock, they never could unlearn it. They just kept doing it on and on and on. Even though, if you think about it, if they're doing this successfully, they are avoiding the shock and they're never getting shocked again. And so you can completely just disconnect the shock, but the animals will continue to jump on and on and on. And we see this in humans as well. The camera that the police department might set up on University Drive to issue speeding tickets could be turned off, but I would still slow down if I didn't know this, right? As soon as I saw the device, I would still slow down, even if it didn't mean that I would get a ticket. The people that I thought were mean and nasty could begin to be nice, but I would never know it, right? Because I'm avoiding them. So that's the issue with avoidance learning, is that the avoidance persists even when the original threat is completely gone. So how is avoidance learning learned? And how come it does not go through some kind of extinction process? Why does it not extinguish? So we're going to look at some theories that help explain avoidance learning. The first one is called two-factor theory. Factor one involves classical conditioning. So in this case, the tone or the light becomes associated with shock and produces a fear response naturally. So tone, shock, tone, shock, tone, shock. Do that a few times, and when the tone comes on, any reasonable person is going to be afraid. So that's the idea, that you develop this association between the tone and fear in the first part, the classical conditioning part. The second part, the second factor, involves operant conditioning, where the response, in this case, say for the rat jumping over the barrier to the other side of the compartment, turns off the tone or the light. Now, again, because of the classical conditioning, the rat does not want to see the light, does not want to hear that tone because it's afraid of it. And so turning off the tone or turning off the light reinforces the jumping response through negative reinforcement, the removal of something unpleasant, which we like, feels like a form of relief. So the jumping response doesn't extinguish, because every time we jump, every time we do something that turns off the tone or the light that we're afraid of, we are rewarded by that negative reinforcement, that relief. So researchers kind of quickly figured out that, oh my gosh, is avoidance learning kind of similar to OCD? In obsessive compulsive disorder, people compulsively will have some response that they make over and over and over again, avoiding, in their minds at least, something horrible. So they might check locks over and over again. They might wash their hands over and over again. They might count numbers in their heads over and over again, all in the hopes of preventing something from happening. So that's the idea of avoidance learning, at least in terms of the two-factor theory. There's another theory, though, cognitive theory of avoidance. So for rats, in this avoidance learning experiment where a light or a tone comes on, and then if they jump to the other side, they turn off that light or tone and they don't get a shock, right? For rats in that kind of an experiment, jumping while the tone is on or while the light is on leads to an expectation of safety. And every time they jump, they are safe from the tone or from the light that they've learned to become afraid of because it led to them getting shocked in the past. So even if the shock is now disconnected, they continue to jump. And each jump that they make confirms the belief that it was the jumping that made them safe. So here in the cognitive theory, the critical component is that the behavior confirms this cognition, this belief that develops that it's the jumping that is what's keeping them safe. And if we think about it in terms of human situations, Lucky Charms work this way. So if I have a Lucky Charm, I can say, oh, whenever I have my Lucky Charm, I am safe. I haven't had a car accident in 5 years because I've had my Lucky Charm. So I can attribute some good outcome to the fact that I've been using this Lucky Charm. And every day that I don't get into an accident confirms my belief that it's the Lucky Charm which is keeping me safe. So this belief gets strengthened every time the person, in this example, goes out with their Lucky Charm and returns safely. There's also another theory called the safety signal explanation. Now, the safety signal it's kind of like cognitive theory, but it's that the response that is made provides a signal that you're now safe. So making the response provides this signal that the shock is not going to come. So for a rat in an avoidance learning experiment, when the light or the tone comes on, they're expecting a shock. When they make their response and they jump over to the other side of the compartment, the physical sensations involved in jumping over are the signal that they're now safe. So that's just the idea that you're doing something and that your action becomes a sort of safety signal telling you that you're safe. And once again, you feel this relief, right? So it's a sense of relief that you've done the right thing. So given that avoidance learning is so easy to develop and can lead to a response that just continues, goes on and on and on, even when the situation no longer really is dangerous and the situation no longer calls for this, well, how can we get rid of this? How can we eliminate these avoidance responses? And the answer is really just two words: response blocking. You have to prevent, in this case, the animal, our little rat, from jumping over to the other side, right? So regardless of the theory, whether it's two-factor theory involving classical and operant conditioning, where jumping over leads to negative reinforcement, or if it's cognitive theory, where every time the rat jumps and he doesn't get a shock, that confirms his belief that it's the jumping that's responsible, or if it's safety signal, that the sensation of jumping over to the other side sends a signal that he's now safe. Any one of these three, regardless of which of these three is really what's going on, we can force the rat to stop jumping by raising the barrier, prevent the response in that way. And so the light or the tone comes on, this poor little guy starts getting really nervous because he wants to jump over to turn off this evil light because he thinks it's going to lead to a shock. So at first, not being able to jump causes lots of anxiety. But after a few experiences, a few trials, he's going to look around and go, hey, wait a second, I am now safe. I used to get shocked when the light or the tone came on, but now it looks like it's not happening. And so you have to essentially force him to stick around here and learn that it's safe not to jump.